Hello, my friends. Let's talk about parametric and vector functions. So first of all, you may be wondering what's a parametric or vector function? Well, a parametric function will be expressed in terms of a parameter. So let's just write it down there. Express in terms of a parameter. So for example, if you see, usually you will see like f of x, y is equal to f of x, which is equal to something. But in this type of functions, we will have x of t is equal to something, and y of t is equal to something. And the set of these points will just make up the function f. And then the t inside this one will be the parameter. And what about vector functions? Well, in physics, you may have learned that vectors have like a magnitude and direction, and it's kind of similar. So usually in AP calculus, you will see that these functions are expressed in a vector bracket, and you have like x of t comma y of t. So it's like a kind of like a parametric function, but there's like a direction too. So let's move on to some practice questions to implement these skills. In this question, we want to find the first derivative and also the second derivative of the parametric function. And we see that x and y are expressed in the parameter t. So x of t is just t plus 1, and y of t is equal to t squared plus 6t. Now you may be wondering, if all of these functions are in terms of t, then how can we find dy over dx? Well, for this one, we can just use chain rule. We observe that we can find dy over dt, and we can find dx over dt. So using chain rule, we have dy over dt times dt over dx is equal to dy over dx, which is what we want to find over here. So how should we find these? Let's just differentiate these equations. So dx over dt is just equal to 1. dy over dt is just equal to 2t plus 6. So dy over dx is equal to 2t plus 6 times 1, or just 2t plus 6. So at t equals to 3, dy dx is equal to 2 times 3 plus 6, which is equal to 12. So in other words, the slope is equal to 12. One common misunderstanding or like mistake of this kind of question is that students may put like dy over dt or as the slope, but that's not right, because even though if it's expressed as a parameter, the function is still on the xy plane. So we need to, so only dy over dx is the slope. Okay, so now we have found this. Let's try to find the second derivative. So, well, we should just use chain rule again. So we know that d2y over dx2 is just d over dx times dy over dx. And this, we can use chain rule, which is just d times dy over dx dt times dt over dx. And if we differentiate this in terms of, if we differentiate this in terms of t, we have, so this will be equal to 2, and dt dx is just 1, so d2y over dx squared is 2, so it's positive, and it means that it's concave up. And I have seen a lot of a common mistake is like people will just try to square it, but remember that the second derivatives notation, it looks like it's squared, but it actually this means this. And another thing is you can't just directly take the derivative of this function because it's written in terms of t, not like x. So you can only like take the derivative with respect to t and then find the first derivative. Alright, so that was the first question. So in order to find the arc length, we just use the arc length formula. If you are not familiar with it, consider checking out our previous video in this series. So now let's find dy over dt, which is just like power root 3 times 2t squared, which is equal to 6t squared, and dx over dt is 2t. So it's just equal to from 0.2 of the square root of 36t to the power of 4 plus 4t squared. And we can take out a factor of 4t squared, so 2t, and then 36 divided by 4 is 9, so 9t squared plus 1 dt. And we can perform a u substitution because we notice that the derivative of this function will be like a constant times t, which is over here, so it will cancel out. So du is equal to 18t dt, so dt is equal to du over 18t, and u of 0 is 9 times 0 plus 1, and u2 is 9 times 4 plus 1, which is 37. So this is equal to 1 to 37. So t square root of u du over 18t. So 1 over 9, 117. So it's equal to u 2 over 3 over 2, 2 over 3. 37. So it's 2 over 27, 37 to the 3 over 2 minus 1. So that will be the arc length of this curve. Okay, now let's move on to the next question. The position vector, now this is a vector function. We see it's a position vector. And we can see these type of brackets. So this is a particle moving in the xy plane, and what's the slope of the tangent line? So we recall chain rule, like slope of the tangent line is dy dx, which is equal to dy over t dx dt, because this one is just x of t, and this one is just y of t. So dy over dt is just 16 times 1 over 2, so 8 over square root t, and dx dt is just 10 times 1 plus t. So at t is equal to 4, dy over dt, 8 over square root of 4, which is 8 over 2, which is 4, dx dt at t equals to 4, 10 over 1 plus 4, 10 over 5, which is 2. So we just plug it in. Dy over dx is dy over dt, which is 4, over dx dt, which is 2. So the answer is that the slope is 2. Okay, so that was it for the practice questions. And now let's just do a real AP exam question for practice. And notice that it says that it's question 2, and the first 2 questions allow the usage of a graphing calculator, which is great. Now let's look. So let's read the questions carefully because this type of questions tend to have a lot of traps. At time t, the position of a particle moving in the xy plane is given by the parametric functions, where dx over dt is t squared plus sine 3t squared. So this is the velocity of x. So this is not x of t, it's dx over dt. And then we have y, that is consisted of 3 line segments in the figure above. So this is y of t. And now we have the initial conditions. At t equals to 0, the position is 5, 1. So let's take a look at A. Find the position of the particle at t is equal to 3. So y of 3 is easy to find. We just take a look at the graph. This is t is equal to 3, and it looks like a straight line, so this should be negative 1 over 2. What about x of t? Well, if we want to find x of 3, we can x of 0 plus 0 to 3 dx over dt, and x of 0 is 5, so it's 5 plus 0 to 3 t squared plus sine 3t squared dt. Let's put it in our graphing calculator. So also make sure that your graphing calculator is in radians, because in calculus we use radians. Okay, so we found that to 3 decimal places, x of 3 is 14.377. Therefore, we find the position is equal to 14.377, comma, negative 0.5. Now let's find the slope of the tangent line of the particle. So the tangent line slope is found as dy over dx, which is equal to dy over dt times dt over dx. What's dy over dt at t equal to 3? Well, we can just directly find it on the graph. It's a positive 1 over 2, so 0.5. What about dx over dt at t equals to 3? Well, it's just 9 plus sine 3 times 9, or sine 27. So we plug that in our calculator and get 9.956. So dy over dx is just equal to 0.5 over 9.956, which is equal to 0.0502. So therefore, the slope is equal to 0.0502. Let's now try to find the speed of the particle. Notice that the speed of the particle is different from that of the tangent line, because the tangent, unlike like one-dimensional movement, the slope of the tangent line just represents like the path, but it's not related to the speed. So the speed is just, well, there's speed in the x dimension and speed in the y dimension. So we need to use Pythagoras theorem. And this is just knowledge from physics 11. But we find that the speed of x is just dx over dt, so 9.956 squared plus 0.5 squared. And then we can use a calculator square and take the square root, which is equal to 9.969. Now let's try to find the distance of the particle, distance the particle traveled. So notice it's the distance, not the displacement, and it will be like equivalent to the arc length. So we just use the arc length formula over here. And we know that v of x is just dx over dt, so we have this, but we don't have v of y, and it's from 0 to 2. So there's actually like two functions that express v of y. Over here it's -2, but over here it's 0. So let's split the integral into two. It's from 0 to 1 and 1 to 2. So it's 0 to 1, and then like dx over dt squared plus -2 squared plus 1 to 2 dx over dt squared plus like 0 squared, which, because this is 0, it's equivalent to the square root of dx over dt squared plus 4 with respect to t plus 1 to 2 dx over dt. So we can put this in your graphing calculator. Let's just find the first integral. So it's the square root of dx over dt, which is x squared plus sine 3t squared. Sorry. But on the graphing calculator, you can only input values as x. So let's square this and then add 4. So the first half of the path is 2.23787. And then the second part of the path from 1 to 2, x squared plus sine 3x, which is around 2.1120, which is 4.350. So that was it. Thank you so much.